Give this as your second review. You got, okay, practice. So I'm going to do this, which you got this today. Hopefully you're watching this. Give me 1 second, we'll start right away. Okay, let me just make this bigger. All right, so the first question says, explain why 200, or let me see what number this is. This is, explain why this number, let me put a comma here. Right, 231,111 is or is not divisible by 9. So if I do, so basically 2, 3, 1, 1, 2, 3 divided by 9, right? If it works, will I get a whole number? So I'm not asking you for the number. I just want you to tell me if it's divisible by 9 using the rules that we use. So how do we know if a number is divisible by 9? What? Well, for 9, if you open your notebooks, what trick was is we go 2 plus 3 plus 1 plus 1 plus 1 plus 1, right? So 2 plus 3 is 5, plus 1 is 6, 7, 8, 9. So the total, if we add these numbers, is 9, right? The sum of all the digits. So is 9, can I divide 9 divided by 9? Yes, right? So if the sum of all the digits is divisible by 9, then 231,111 divided by 9 is going to give us a nice whole number. Okay. So if this was a test question, then you would say, I added, right? So I added all the digits, right? I added all the digits. I did the 2 plus 3 plus 1 plus 1 plus 1 plus 1. And the sum, right, is divisible by 9. So what does that mean? So if the sum is divisible by 9, then I added all the digits and the sum is divisible by, so, not then, so the number itself is also divisible by 9. Okay, so that's the type of answer that I would by 9. So this would be what the work that I would like to see on your quiz. You adding it up and explaining what you did. Okay. Next one is 1,536 divisible by 6. How do I know that? Is it or not? So the rule for 6, remember, is if it's divisible by 2 and divisible by 3. So if it works, if it's yes for 2, yes for 3, guess what? Then for 6, it's going to be a yes. Well, so first of all, is it divisible by 2? Well, the last digit over here is an even number. So it is divisible by 2. So you can start writing, it is divisible by 2. Right? It is divisible by 2 because it's even. It is even, right? It's an even number, so we know it's divisible by 2. Is it divisible by 3? So what was the trick for 3? The trick for 3 is the same for 9. So we get 1, we add to 5, we add to 3, and we add to 6. And let's see what we get. 1 plus 5 is 6, 6 plus 3 is 9, and 9 plus 6 is 15. So is 15 divisible by 3? Yes, it is, because 15 divided by 3 is 5. So what does that mean? The whole number is also divisible by 6. So it's divisible by 2, and this is also, it is divisible by 3. We just did that, right? It's divisible by 3 because the sum of the digits, right? Because the sum, la suma, of the digits, de los números, of the digits, is divisible by 3. Divisible by 3. So that's a little trick, right? Notice that we're not trying to find the answer. It's just queremos saber. We want to know if it's divisible by 6. So it's divisible by 2, yes. It's divisible by 3, yes. So if it's divisible by 2 and 3, then yes, it's going to work for 6. So it's divisible by 2 because it's even. It's divisible by 3 because the sum of the digits is divisible by 3. So then, if it worked for 2, then it will also también then will also be divisible by 6, right? Isn't 6 2 times 3, right? 6 is the same thing as 2 times 3. So let's move on. Number 3 is 12. It's 8,968 divisible by 12. So what was the trick with 12? The trick with 12 is very similar to the trick with 6, right? We have to check if it's divisible by 3 and check if it's divisible by 4. If it's yes and yes, then 12 is divisible. Then it's divisible by 12. So is it divisible by 3? Well, let's add a number. 8 plus 9 plus 6 plus 8. 17, 17, 6 is 23. 23 and 8 is 31. 8 plus 9 is 17. Yeah, so this gives you 31, right? And is 31 divisible by 3? Is 31 divisible by 3? No. So 3 is a no. We don't even have to do 4, right? Because already 3 is a no. So let me just do 4. 68, right? So for 4, we look at the last two digits, right? And we have 68. 68 divided by 4 is equal to 17. So 3 is a no, but 4 is a yes. But we need a yes and a yes. So is it divisible by 12? No, it is. It's not divisible by 12 because it is not divisible by 3. Okay, and 4. It has to be divisible by 3 and 4. In this case, it's only divisible by 3, right? But not 4. So I think actually not divisible by 3. That might confuse you guys. So it's, let me write this. It's not divisible by 12 because it's not divisible by 3. And it's only divisible by 4. And it's only solamente divisible by 4. Okay? Now here, the next question has it's a little different. So we have the number 5, 3, 3 space, 2, 2 space. We want this number to be divisible by 3 and to be divisible by 5. So what number can I put here? ¿Qué número puedo poner aquí? What number can I put here so that it's divisible by 3 and divisible by 5? So I know one thing. If it's divisible by 5, the last number has to be 0 or 5, right? So let's choose 0. If the last number is 0, it's divisible by 5, yes. Now, if it to be divisible by 3, I have to add 5 plus 3 plus 3 plus this number plus 2 plus 2 plus 0, and that has to be divisible by 3. So what do we have so far? 5 plus 3 plus 3 plus something plus 2 plus 2 plus 0. That equals 5 plus 3 is 8. 8 plus 3 is 11. 11 plus 2 is 13. 13 plus 2 is 15. So far I have 15, but I have to put a number in here, right? So is 15 divisible by 3? Can I divide 15 by 3? Yes, I can. So you know what? We don't have to change the number. We can just put a 0 over here. So if we put a 0 over there, we get 5 plus 3, which is 8 plus 3, which is 11, plus 0 is 11, plus 2 is 13, plus 2 is 15, and then plus that 0 is also 15. So 15 is a nice number. You could have changed it, all right? So let's say you wanted a different number. So you have 15, right? The sum right now, the sum is 15, but if you add a 3, let's say you add a 3 here, it would be 15 plus 3, you would do 18, right? You would get 18. Is 18 divisible by 3? Yes, it is. So that our final number could be 5,333,220, which is 5,333,220, or the number we had before, which was 5,330,220. So these two numbers I can divide by 3, yes. Divide by 5, yes. This is the bottom number, I can divide by 3, yes. And I can divide by 5, yes. Okay, so not that difficult question. So the bottom one says, find all the factors first and then tell me if it's prime or composite. Okay, so let's find all the factors. So let's go 1, 96, 2, 48, 3, 32, 4 and 24. No, 5, 6. Yes, 6 and 18. No, 6 and something. Sorry, 6 and 16. 7, no. 8, no. 8, yes. Sorry, 8 and 12. 9 is a no. And then that's it. So this has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 factors. So this is definitely composite, right? Because it has more than 2 factors. 71. We got 1 and 71. Is there more? 2 is a no. 3 is a no. 4 is a no. 5, no. So there's only 2. So this is a prime number. There's only 2. And then we take this. There's only 2 factors, right? 1 and 71. 72. Ooh, that has a lot. 1 is 72. 2 and 36. Let me put commas. 3 and something, 24. 5 is a no. 6 and 12. And then 8 and 9. So this is definitely composite. And then, oh, I have, okay, let me finish this first. 64. 1, 64. 2 and 32. 3 and 18. No, wait, what am I doing? 3 doesn't work. 4 and 16. 5 doesn't work. 6 and 8. So you can see that this is also a composite number. So I forgot the other part. So that was number 1. Is it an emerp? Emerp, remember, so 13 is an emerp. Why? 13 is prime. And when we change 13, it becomes 31, right? We switch position. Is it also prime? Yeah, so it's prime and prime. So this one is a composite. This one is a composite. This one, so it's not emerp, not emerp, not emerp. But 71 over here is a prime. If I switch it, it becomes 17, which is also prime. So this is an emerp as well. And perfect square is 96, 72, 71, or 64, a perfect square. The only perfect square here would be 64. So this one is also a perfect square. Why 64 a perfect square? Because 8 times 8. So 64 is a perfect square. Okay. Okay, so let's go to the next question. Okay, so this one is the easy stuff, right? You guys. So the expanded form. So let's do 14 squared. So the easy ones. 14 times 14. 14 times 14 is 196. Exponential form is 14 to the second power. 2, 1, 2, 3, 4, 5, 6, 7. So it'll be 2 to the 7th power. We write 2 to the 7th power. Okay. And it's 2 times 2 times 2 times 2 times 2 times 2. So 2, 4, 8, 16, 32, 64. So the answer is 128. 10 to the 9th power. So we're going to write 10 to the 9th power. And we write 10 times 10, 3, 4, 5, 6, 7, 8, 9. So, and that's 10 times 10, so 9 times, right? So the trick was when we have 10 is just we can write 9 zeros, right? Because of power. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And there's our $1 billion. 343. Ooh, 343 has to be to the 3rd power. Hang on. 343. I don't know what it is. Alexa, what's the cubic root of 343?
The cube root of 343 is 7.
Oh, sorry, I forgot. So this one, 343 would have been, it's 7 times 7 times 7. Exponential form, 7 to the third power. In word form, I'm going to write 7. That should be right. Remember, 7, we have a different way of saying when it's the third power. We can write cubed. Okay. Bottom one, again, this goes to, and I don't know if I'm going to let you use a calculator here because I'd like you to memorize or to learn those divisibility rules that we learned. Is a number divisible by 2? How do we know? If it's even, so is 46 even? Yes. I'm gonna just write a check. Put an X here. It's even. It's divisible by 2. 156 is even. 64 is even. And 480 is even. So all these numbers are divisible by 2. Is it divisible by 3? What do I have to do? I have to add a number. 4 plus 6 is 10. Is 10 divisible by 3? No. 1 plus 5 is 6. 6 plus 6 is 12. Is 12 divisible by 3? So yes, over here. 64, is that divisible by 3? Well, 6 plus 4 is 10, so that doesn't work. 480, is it divisible by 3? Well, 4 plus 8 is 12. 12 plus 0 is 12. Is 12 divisible by 3? Yes. 4, how do we check? Divisibility for 4, we check the last two numbers. Is 46 divisible by 4? No. Is 156 divisible by 4? Yes, because the last two numbers, 56, can be divided by 4. So 64 divisible by 4? Yes. Is 480 divisible by 4? 80 definitely is divisible by 4. So that's okay too. 5, the only one that's divisible by 5 is 480 because it ends in a 0. Divisibility rule for 6. For 6 has to be 2 and 3. So which of these numbers have 2 and 3? Well, 156 has 2 and 3, so 6 is going to work. And 480 also is divisible by 2 and 3, so 6 is going to work. Is it divisible by 8? Look at the last three numbers. So that's a no. 156, 1, 7, 8, 16, that's a no. 64, yes. 480, yes. Divisibility by 9, we add all the numbers. 4 plus 6 is 10. Is 10 divisible by 9? No. 1 plus 5 and 6 is 12. Is 12 divisible by 9? 6 plus 4 is 10. Is 10 divisible by 9? No. 4 plus 8 plus 0. Is that divisible by 9? 4 plus 8 is 12, and 12 plus 0 is 12 still. Is that 12 divisible by 9? No. Divisible by 10 ends in 0, right? So the only one that ends in 0 is this one. How do you know if it's divisible by 12? Well, divisible by 12, it has to be divisible by 3, right? And divisible by 4. So let's check who's divisible by 3 and 4. Divisible by 3 and 4 was 156. You can tell here. Divisible by 3, divisible by 4. So it's divisible by 12. And 480 is also divisible by 3 and 4, which makes it divisible by 12. Okay. Let's scroll down. This is the first 25 prime numbers in order from least to greatest. Oh my god. Alright, so first prime numbers 2, 3, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57 is divisible by 3, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 71 divided by anything? No. 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91. Yikes, 91 divided by 7. Give me a second. Yeah, 91, 92, 93, 94, 95. Oh boy, 96, 97. I think I forgot a couple. 97. Yeah, I definitely forgot a couple here. Okay, so let me just check. Alexa, what are the first 25 prime numbers?
2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 59, 67, 71, 73, 79, 83, 89, and 97, and 97.
83. Sorry, so I forgot 83. Why did I skip 83? 83, 89, 97, and then it would be 101. I think 101. Multiplied by 2, by 3, by 7. No, it's 101. Okay. Sorry, this was 79. Okay, so those are your first 25 prime numbers. Okay. Ooh, I would have lost a point there. Yikes. And then here at the bottom is asking you for the prime factorization. Okay, so prime factorization and write in exponential form. Really important for you to do that. Let's do the easy one first. 96 could be, let's do 6 and 16. 6 is 2 and 3. Prime numbers, circle. Prime numbers, circle. 16 is 2 and 8. 2 you circle. 8 is 2 and 4. 2 you circle. And 4 is 2 and 2. Circle, circle. So 96 is how many 2's? 1, 2, 3, 4, 5. So that's right. 2 times 2 times 2 times 2 times 2 and then times 3. So if you put in your calculator 2 times 2 times 2 times 2 times 2 times 3, you get 96. And in exponential form, it's 2 to the 5th power times 3. 360, we're going to divide it into 10 and 36. 10 is 2 and 5, right? Prime, prime. 36 is 2 and 18. 2 you circle. 18 we can go on to 3 and 6. And oops, don't circle 6. And 6 is 2 and 3. So 360 is 2. How many 2's? 1, 2, 3. 2 times 2 times 2. And 2 3's. Times 3 times 3. And then times 5. So again, if you put that in your calculator, you get 360. Exponential form is 2 to the 3rd power. There's 3 2's times 3 to the 2nd power times 5. So this is the complete answer. Okay. At the bottom, 14, the last question here. So I want you to write in the blank space. Is it always? Right? Always, siempre, sometimes, that's what it says, o nunca. Right? So always. So a number, if a number is divisible by 3, then it's divisible by 9. Is that true? Never true? Or sometimes true? So let's pick a number like 12. 12 is divisible by 3, yes? So if 12 is divisible by 3, does it mean is 12 divisible by 9? Is the answer yes? No, right? So, but what if you pick a bigger number? Let's pick 36. 36 is divisible by 3, which equals 12. So that's a yes, right? So I'm just going to forget the 12 for a second. So can I divide 36 by 3? Yes. Can you divide 36 by 9? Ooh, now it's a yes. So sometimes it doesn't work, and sometimes it does work. So if a number is divisible by 3, then it's also divisible by 9 is sometimes. So over here you would write sometime as veces, funciona as veces. Sometimes it works. If it's divisible by 3, it's also divisible by 9. All prime numbers are odd. 3 is a prime number, 5 is a prime number, 7, odd number, odd number, odd number, 11, 13. But don't forget your first prime number. What's your first prime number? Your first prime number is the number 2. So can we say that all prime numbers are odd? We can write sometimes, right? Not always. No, we can't say that. So the answer is never. We can never say all prime numbers are odd. Can we sometimes say that? I would write never. All perfect squares have 3 factors. So let's look at all the perfect squares. Not all of them, but let's look at a few perfect squares. Let's pick 25. Let's list the factors. 1 and 25, and then 5 and 5, or just 5, right? So how many factors? 3 factors. Let's pick another one. 36, right? 25 is 5 times 5, right? So that's a perfect square. 36, is 36 a perfect square? Yes, it is, because 6 times 6. So does 36 have 3 factors only? 1, 2, 3 numbers? Well, it has 1 and 36. It has 2 and 18. It has 3 and 12. It's 4 and 9 and 6. So is there 3 factors? No. Right? So let's look at number 9. Number 9 is 1 times 9, right? And then 3 times 3. How many factors? 1, 2, 3. So sometimes, why is 9 a perfect square? Because 3 times 3, right? So sometimes perfect squares have 1, 2, 3 factors, like 9, like 25 has 1, 2, 3. But sometimes it has many, many, many factors. Okay, so we're going to write here sometimes. If you multiply a prime number by 2, the product will be a prime number. So let's pick a prime number, 3. Multiply by, so this is prime, right? 3 is a prime. If we multiply it by 2, do we get another prime number? Is the answer prime? What's 3 times 2? 6. Is 3 prime? No, it's not, because 6 is composite. So that statement is not true. Let's pick another prime number just to see if it's always true. Let's pick another prime number. Let's pick a big prime number. 17 is a big prime number. We multiply that by 2, so 17 is prime. If we multiply that by 2, we get 34. Is 34 prime? No, it's not. It's composite. So it looks like if you multiply a prime number by 2, the product will be a prime number. That will never happen. You will never get a prime number that you multiply by 2 and you get another prime number. Okay? That's your review sheet. And here is your first bonus word. Okay? Your first bonus word is going to be cyclone. Okay? Cyclone.